Hey everyone. Today I'm going to go through the display and more importantly how it actually works now. So there was quite a lot of messing about trying to get it to work because previously what it did was there was no off state. So when it would switch from one number to another, the other, uh, the switch would happen instantly, but the number being calculated would take longer. So you'd end up with a little bit of ghosting. And this wouldn't have mattered even if I was actually switching between two different displays because it would ghost on both. So I've had to add in an off state. I'll show you the circuit behind that in a bit, but for now I'm just going to run this, and you'll see while one of them is on, it turns off before it turns the other one on. So while it's off, that's when it does the switch. So it's on, off and switch, on, off and switch, on, off and switch. And it picks up all the right numbers. Right, so this is it in moving slow. So you'll see it does actually turn off, but I'm going to remove the capacitor, the headers that slow this down. And you'll see there's no flicker in person either. It does look quite nice, and yeah, that's all working now. And yeah, it just does its thing. So yeah, this is all going through the adder, through the multiplexer and the clock that does the display. Then it goes into like the 4-bit stuff, which then switches here. So yeah, what it's doing here is an overflow. So that's all 1 bit. So if you add 1 to that, it sets all those to 0. But there's no 9th bit displayed, so yeah, overflows. Right, so I can show you the circuit for this. Right, so it's this one here. So on the top here we have the actual clock. It's just an an astable multivibrator. So it's got a couple, 4 capacitors, but when you have these pins removed, because they're usually shorted with that, it uses the small caps and ignores these. Yeah, it's got a couple of LEDs there just to show you it moving, but obviously when it's moving at such a high frequency, you don't even know. But yeah, and at the bottom is the multiplexer. So this takes the 8 bits and outputs the 4 bits. And in the middle is the new board. So this is basically a flip-flop, and it acts as a frequency divider, but it has some outputs as well. So when this switches, on this pulse, it will swap this one, then go back, and this will keep whatever's output was whatever state it was in before. So this is used for the switching now, and this is used for turning the display on and off. So when this light's on, the display is off. Actually, no, I can't run it because my power's over there now. Hold on, here we go. So I'll put these back in, and I mean, there's no LEDs on this flip-flop, so you'll just have to take my word for what's happening. And here we go. Right, so you don't know if you can see it over here as well, just here. So when it's red, it's on. When it's pink, this changes, the flip-flop changes, and it's off. So it's on it's on. When it's pink, it swaps and turns the thing off. And when it's red again, it turns back on, but with the new number, because this remains the same until this one goes again. So it only swaps when it's off, so you never see the swap. So that's how that works. Took a bit of trial and error to get there, but yeah, it's quite nice. I have actually set this up with this stuff now. So I built a new board. This is just a load of NOT gates, or one's complement. because it's part of the ALU, you can call it ones complement because it's the inverted of the number, the inverse of the number. And I actually needed this. I actually need this for subtraction, because to do subtraction using an adder, you negate the number, then add 1 to it, and then add it to the other number. And magically, that subtracts it. So adding 1 to 1's complement makes it 2's complement. So it's actually like the negative number. Yeah. And I did that. This does work with the register. So tying the ALU directly to the register didn't work because this requires that the input can also sync current, and this does not sync current. This, however, does sync current, but it's the wrong number. It's inverted. So I'm going to have to do some other stuff. The ALU will have a multiplexer anyway, so that you can choose what number it's outputting, whether it's outputting addition, subtraction, logical arithmetic like AND or XOR, that stuff. So there'll be a multiplexer to choose between which one of those is outputting to the register. Yeah, and so that'll be the correct number when it actually gets here. And it will sync current. So, yeah. Let's turn this off. Oh, actually, let's get a better power solution here. Right, let's do a little bit of post. Okay, I've only got the one thing, but it's a big thing. Which is the way still. Ow! Jeez. There's a lot of sharp bits on that. Okay, here we are. Well, this is wrapped up in it. So I know what this is, and this is for testing. Well, getting to better know these things. So this is a transformer. So what this is for taking AC from the mains and stepping it down to a different voltage AC. So this is 240 volts to 9 volts, yeah. And when it's down at 9 volts, I can convert it to DC and run the PC off it. So this would actually be, so because this is a discrete build, I want it as discrete as possible. At the moment, it's just using an AC to DC plug, but I actually want the whole thing to run off AC. So this will just convert that down to like a more reasonable voltage, and I know how the circuit for AC to DC already works. So, oh, pardon me. We'll see how that goes. But this is just for experimenting for now. I'm not actually going to put it in here yet, because yeah, I need to test it. I need to experiment, get to grips with it more, because I don't trust myself. I don't understand this stuff too much. But yeah, that'll be interesting. I'll see what I can do with that. But yeah, that's everything. I've actually got a lot more. I should have a lot more posts for next week. Still all related to that. But yeah, thank you for watching, and I'll see you later.